There were some questions on lecture today, it's Friday, March 19th, about the traverse correction, which I wanted to give you another quick demonstration of. And here's an example. Down here in the bottom left, I have the triangular layout, and I've already written in the azimuths and departures for each of these legs. Leg 1 to 2 has an azimuth of about 74 degrees. Leg 2 to 3 is about 178, and leg 3 back to leg 1 has an azimuth of about 331. And that's the information that we need, along with the distances, to calculate the latitudes and departures. We need one more thing to calculate coordinates, which is a starting point coordinate. So let's get those written in. And in this case, those coordinates are 1169.43 and 1233.20 in the north. Now, let's go through the process. For each one of these, I am going to calculate the delta east, that's the departure, and the delta north, that's the latitude. And these come about from the departure is going to be equal to the distance times the sine of the azimuth angle for that leg, and the latitude is going to be equal to the distance times the cosine of the azimuth angle. And these are the data that are given to us up here. So using those, 74.808 and a distance of 226.893, I am going to get, for my first latitude and departure, the following. My delta east will be 218.96, and my delta north will be 59.46. And now quickly fill in the same information for legs 2 to 3 and 3 back to 1. And now I will calculate the coordinates for each point. And the coordinates for point 2 will be the, let's do the east first, will be the coordinate for point 1 plus the delta east from 1 to 2. So 1169.43 plus 218.96 is going to give us 1388.39. And for the northing, 1233.20 plus 59.46 is going to give us 1292.66. And again, I'll do those for the other two legs. Okay, and now let's see how we've come out. What's the difference between our beginning coordinate for point 1 and our ending coordinate for point 1? Well, in the east, it's going to be 0.856. And in the north, it is minus 0.754. One thing to note here is that you can actually calculate these two ways. One of them is by subtracting the initial evaluation of the coordinate from the final, or the other way around. The other one is add up the deltas, and that will give you the same thing. All right, so now we've got a misclosure that is big enough to be concerned with, but small enough that we don't really need to do the survey over again. Let's fill in a few more details over here on the left-hand side. The linear misclosure, which is simply the length of the vector with these two components, delta east and delta north, and that comes out to be 0.88. And the relative misclosure is that linear misclosure divided by the sum of all of the lengths, the perimeter, and that belongs over here. And let's do that quickly. I'm just summing up the three distances, and those come to 1183.81. So the relative misclosure would be 0.88 divided by 1183.81, and that is equal to 0.00074. All right, so now let's do the next part of this. Our misclosures mean that we have, in the course of going around the circuit, picked up an extra 0.856 in our east coordinates and lost a 0.754 in the north coordinates. And in order to correct this traverse, or to eliminate this misclosure, we could simply subtract 0.856 from the east coordinates anywhere we please and add 0.754 back in anywhere we please into the north coordinates. A slightly more sensible thing to do, though, would be to divide the misclosures evenly among the three legs. So what we could do is, let's say we are correcting the east, and I'm going to make the corrected value, make that a star, and let's take the leg from 1 to 2, would be equal to the original delta east from 1 to 2. So that's up here, that's that 218.96. And I would subtract from it a third of the east component of the misclosure. And then similarly for 2 to 3, that would be equal to the original 2 to 3 minus a third. And from 3 to 1, oops, keep forgetting to put the east in, 1 would be equal to delta east 3 to 1 and subtract a third from there. So then I've subtracted altogether the entire misclosure delta E from the easting. And I do the same thing from the north. However, we can do a little bit better than that. And rather than dividing the misclosure up into 3 equal parts, why don't we divide it up into parts that are bigger for the longer legs? You notice that leg 2 and 3 are more than double the length of leg 1. So it makes sense to put more of the correction into those longer legs. And here's a way to do that. I'm going to subtract, or I'm going to get rid of these 1/3 values here. And in their place, I'm going to put a weight 1, weight 2, and weight 3, where the weights are equal to the fractional part of the distance. So weight 1 would be the distance of the leg from 1 to 2 times the sum of the distances. Weight 2 would be the distance from 2 to 3 divided by the sum of the distances. And weight 3 would be equal to the distance from 3 to 1 divided by the sum of the distances. And those are very easy to calculate. We've got all the numbers over here on the left. We've got our weight 1, our distance 1 divided by the sum of the lengths, distance 2 divided by the sum of the lengths, and so forth. So I am going to calculate these values here, and I'm going to write them in over on the right-hand side of this table under the delta E asterisk and delta N asterisk columns. And then we will add those latitudes and departures to our original coordinates, 1169.43 and 1233.20. And again, those numbers never change because we do have to have one point which stays fixed. We don't have any way of detecting or correcting for a translation error where the entire triangle is picked up and moved somewhere without changing its shape. So let's do that. And in the first case of the corrected delta E from 1 to 2, the value is going to be 218.80. And the northing is going to be 559.60. And then adding those to the original coordinates for point 1, we have corrected coordinates for point 2 of 1388.23 and 1292.81. And let's do one more, and I want to emphasize something here. The corrected departure and latitude for the leg from 2 to 3 is going to be 11.06 and minus 478.81. And then the corrected coordinate for point 3, I am going to add the 11.06 to the 1388.23. So these are incremental. Each one of the deltas takes you from the previous coordinate to the next one. And those results will give us 1399.29 and 813.99. And let's do the last step quickly. And now we can see that the final coordinates for point 1 match the initial coordinates for point 1, and we have a 0 misclosure. And that should not be surprising because we know exactly what we had to change to make it come out right. We divided those misclosures up by amounts that would add together, all those weights add together to sum to 1. And so when we add those three parts together, we have the full correction for the east and the full correction for the north. So that's it. That's the entire procedure. And it is pretty cut and dried. You can apply this without modification to pretty much any problem, as long as you have the data in this form of azimuth and distances. I mentioned before, and we've done a little bit of it, very often your survey data comes in terms of the interior angles and the distances. And that requires a little bit of work to get from interior angles to azimuths, but once you're there, the procedure is exactly the same.